Hello, hi everyone. Welcome back to my YouTube channel. So today in this specific discussion, we will be discussing about a very interesting topic that is about vectorless RAG. Few months ago, I would say almost 6 months back, I have published one of my playlist of Inside Generative AI, where I have talked about the core concepts of prompt engineering, agentic AI, what exactly is happening in the world of generative AI. And in that, I have talked about RAG as well, retrieval augmented generation. And today, I will be adding one more episode on top of that, which is talking about how the traditional RAG is no more useful right now. So, over here, I'll just revisit the core idea of what was there in the traditional RAG, and afterwards, we will see that what is happening right now in the industries and why, that vectorless RAG concept came into picture. What was the major limitation of traditional RAG? We have learned a lot about vector DBs, right, at that moment. Now, what could be the possible issue and why we are not right now using any vector DB? And we are trying to completely shifting towards this vectorless RAG using this page index. So a lot of stuff is coming up in this video. Please try to watch the session till the very end. I hope that you will enjoy that. And if you do, please hit like button, share the video with everyone. And with that, let's get started. Now I hope that my screen is perfectly visible to everyone. First of all, let's talk about what was happening in the case of traditional RAG, right? And you will find the code implementation and everything about this in the same playlist of Inside Generative AI. So if anyone wants to have a look onto it, you can just definitely have I think it's episode number 3 or 4. You can just watch that out and you will get to know the code implementation also. But that's the stuff which I have talked about over there as well. So in the traditional RAG, there were two concepts. There were two, I would say, steps which we were doing. The first step was about indexing, and the second step was majorly about retrieval. Okay. And the main idea about this indexing is that if, let's say, we will be having a very big PDF document, and that is something which is confidential. I don't want to share it to the public as well. And even if it's not confidential, but the size is too huge, and I want to retrieve, let's say in future, any data from it. So what was the idea? Ki we can upload that complete PDF document inside this RAG-based system. So what was happening over there is, in the indexing part, the main idea was that, first of all, we will try to create a chunks of that PDF. So let's say I have this very big PDF. I have this very big file available with me. So usually the first concept was ki let's do a chunking of this. Chunking means splitting that into multiple, I would say, chunks. So that step is what we are calling it as a chunking. Right? That's what we have learned in our last discussions as well. Now, after this, obviously, our system internally won't be able to understand the PDF format. It could be in a textual format, right? So the main idea is how can we convert that into vectors, into numeric vectors, I would say. And that process is what we call as embedding, right? So the next step was ki we have multiple chunks. Maybe there is a window size with respect to these chunks. So let's assume that we have tried to create multiple chunks over here. This is first chunk, second one, let's assume third one, fourth one. And now what was happening is that with these multiple chunks, maybe I will allow a limit of, let's say, 500 words or 1000 words in one chunk. Now over here, this is basically being converted into a vector. And this concept, as I have mentioned, is what we call as embeddings. So the next step is converting these chunks, the textual form values, into the numeric vectors, and that is what we call as embeddings. Now, once we have the numeric vectors and once we will be able to create the embeddings of it, the idea was very simple. Where to store these embeddings, where to store these numeric vectors. And that is where we have understood in our previous discussions, the concept of vector DB will came into picture. So over here, we have a DB called as vector DB. Now there could be several examples of this, which we have learned in our previous discussions. You might find that my practical implementation in the playlist is actually based on, I think, quadrant DB, but you might have learned about several examples like chroma DB is one of the example. Then quadrant DB is another example, right? Quadrant DB is another example. We might have pinecone. So in this way, we will be having a lot of vector DBs listed over here, right? These are the few examples which I have mentioned over here, but in the industries, you might find others vector DBs as well. One of them which I'm able to recall right now is PG vector and so on, right? This is a very big list. And almost every startup at that point of time is definitely relying on these vector DBs to store these embeddings. Now everything was smooth. I mean, there's not an issue over here. We will be having the embeddings available over here for this entire PDF. Now what was happening, this was the core idea of what we called as indexing. So if I can remove over here, I can say that this was what is happening in the very first step of indexing. Now things were very simple, very smooth, and there was no as such issue over here. But later, it is being realized that let's say if I will be having a very big paragraph or a document, and I'm trying to make a split of that based on, let's say, the limit which I have set, maybe 500 words or 1000 words. So obviously, if let's say I'm having this, let's say this paragraph, and over here, maybe in one of the chunk, until this specific part will go, vector-based RAG retrieves information using semantic embeddings. And then in the next chunk, let's say the next chunk value will start from and similarity search over chunk text stored in vector DBs, while effective in many scenarios. Then third chunk, let's say store, this approach faces structural and reasoning limitation when applied to long, complex or highly structured documents. Now what is happening? You will observe that the way I have splitted down these chunks based on the limits, it might lose the context. That's the very first problem. That was the very first limitation. These chunks, it might lose the context, right? So that is the very first limitation that we will be having in this, I would say, chunking approach based on this window limits set that we are doing at the start of the approaches itself in the RAG implementation. Now, okay, that is one thing. So another thing, if let's say, now what was happening in the second part? In the second part is what we said a few minutes back, we have discussed. It was about retrieval. So we are trying to retrieve the document. So let's say now a user came and user is writing any query which the user wants to retrieve. So what was happening is again, there is definitely a model that we are using. There could be a pre-trained model that we are using, which is basically converting our textual values to the chunks, to the embedding, sorry. So over here, the same model we are using over here, and this model is also converting the query which the user is writing. So let me write it over here. User is basically feeding some sort of query. Based on this query, we are again using the model, same model, and that model is actually giving me the embeddings for the same. Embeddings for the same. Now, embeddings are kind of numeric vector, maybe in the form of list, maybe in the form of arrays. And after that, once we will be able to get the embeddings, there will be a similarity search which was happening. There will be a similarity search which was happening. And whichever vector is having a very good or higher similarity search, that specific value will be retrieved back to the user. So what was happening is, so over here, based on, because over here the main information of, I would say, the document is there. So what was happening over here? So it was actually retrieving that information to the user with a high similarity search. Let me write it over here, with a high similarity search. So I hope that everybody can get the idea. And this is something which is, again, I'm saying, not new. This was what happening back then when we have learned about this, I would say, traditional RAG system. Now we have seen that there is one issue which was about that it might lose the context, right? Now the second one was ki, when, let's say, we will be having a very huge amount of data, at that point of time, there will be definitely a very huge amount of storage space which will be required in the form of vector DB. And that's why we're using this deep databases, right, to store our data. Now, let's try to understand that what is happening in this vectorless RAG and how it is basically helping us to avoid that issue of storing our entire embeddings into vector DB. So over here, we have an approach called as tree-based data structure, and that is what we have to learn now. So if you will go and refer any of the articles of this page index, you will see one common thing. Let me just open one Geeks for Geeks article. Maybe after this session, I will attach these references in my YouTube description as well. This is the major thing which you have to understand, that what is actually happening over here. So over here, if you will see this flow diagram, and we'll try to understand this one. And this is what is happening in the vectorless RAG. So we have a document. You can imagine this as a long form of document. We will be able to extract the engine and try to create a structured tree index of it. So basically now what is happening is, if you will see the format of this structure also, this I'll come later on. Maybe over here, this is the GitHub page of this page index. If you will refer over here, this is where they have mentioned the example of this page index tree structure. All these references, again, I will be sharing with you in the YouTube description part. So you can see we will be having a title, node ID, start index, end index, summary, the corresponding nodes of it. So this is how basically the structure of this page index tree part looks like. Now what is happening over here? As soon as the user will enter any query, the way we usually traverse in a tree specific data structure, right? We always start from the, I would say, root node, and then we go traverse step by step and we'll go to the leaf node until we reach to a final result that we are trying to extract from it. If you're at any point of time aware about any of the tree-based data structure, you will get to know what I am saying over here. If you're not aware, you can check my DSA using Python playlist. Over there, you might find the basic tree data structure. What do you mean by nodes? What do you mean by root node, leaf node, internal nodes? All of these things are the basic core data structures that we will be having. So on top of that, this actual thing, what I would say is this page index is being built. So now LLM will process that, will give the results based on the given query, and finally the insights will be shared to the user again. Now over here, when you try to read this, I was just reading with the Medium article as well. Just let me share with you the link for that as well. This is again one of the article. You might find a lot of articles right now available for this page index specific vectorless part. You will find one common thing. It is like reasoning first RAG approach. So over here you can see LLM reasoning to search that tree is in a human-like traceable way to retrieve the information. So you will see over here, instead of chopping text into fixed chunks and searching an embedding space, it builds a hierarchical tree, which is a intelligent table of contents. So this is the main thing which is there inside what we called as page index inside this page index. So hierarchical tree is being formed, and this is where you will see the term called as reasoning first approach. Why? Because as and when we will try to create a, I would say, tree specific data structure, and LLM will give a reason of it. Whenever a user will enter any query, it will try to find the appropriate node where exactly the context of that specific data will be available. The nodes are created in such a way that the context will always be retained. So over here, one common thing which you will observe, that the common issue which we were facing in the above traditional RAG part, this is not there in this page index. So context is retained now, right? Over here, you can, maybe after this session, please go and read it out. So over here, you can see it builds a hierarchical tree, uses LLM reasoning to search that tree in a human-like traceable way to retrieve the information. Now, what page index actually does? First of all, tree generation will happen. So as soon as you will ingest a document, it could be in the form of PDF, HTML. And if you want to convert it into a hierarchical tree of nodes, for example, sections is one node. Inside this, there will be a subsection, there will be a pages. Then LLM-driven tree search will happen. So now, as in when the user will query, there will be a LLM-driven search which will happen in a traceable form, and it will return the node IDs and the content from those nodes, which is used to answer those queries. So there will be no chunking, no vector DB, and this reduces the chunking artifacts and the wipe retrieval failure mode of vector similarity. And that is the main important, I would say, crux of it. This is the main important crux of it, this entire discussion. So let me copy this process, and I really hope that this specific part is pretty much clear to everyone. Right? So this is the step number 1. This is the step number 2, you can say. And this is the step number 3. Perfect. So one thing is very important over here to understand, that the things are changing in a rapid way. And it's very important that, we should have a clarity on what is happening, right? In especially the generative AI world, because there are a lot many things which maybe when you're learning few months back or years back, they could be called as traditional, and something new is coming up. Today we are learning about this page index. Maybe in future, after a few months, I might create some new video where I'll be talking about that, how this became traditional, right? So it's very important that, you will try to understand all of these things in a great way, because foundations are something which will always be helpful for you to understand these advanced stuffs. Also, do let me know in the comment section, do you want me to code this page index or not? Traditional RAG implementation I have done. So if I got multiple comments regarding the implementation of this page index, which is not that much difficult. I mean, if you will just check this GitHub repo, you will get a clear-cut idea how this could be done. But if you still want me to do a live code implementation of it, I will be happy to do that, but I will be just waiting for your comments. So if you really find this video insightful and want me to create a version, I would say part 2 of this specific video, where you want me to write a code for the same, whatever be the explanation I have given to you, that how this tree based structure will be formed in the page index and how this retrieval will happen. So do let me know with that, bye-bye everyone, and I will definitely see you all in the next upcoming videos. Bye-bye. Okay, so before wrapping it off, I just forget to mention one more interesting stuff over here, that again I'll attach this link with respect to this page index chart, where I have tried to explore this. Whatever discussion we have done based on this, it is actually being designed. So over here, what I had done is I had tried to upload one PDF of this Ace the Data Science interview. This is a book by Nick and Kevin. This is majorly designed for data science interview preparation. And over here, what happened is I have given the query with respect to that. Can you just give me the context? What is there inside a SQL interviews part? So you can see that how the structure it is trying to build. And after that, it is just getting the document structure, then page content, and then it is actually giving me a appropriate referencing of it, that okay, it's there in the chapter 8, SQL and DB design, why SQL matters in interviews, then how SQL questions are structured, what are the tips for solving the interview questions, what are the key SQL concepts which everybody must know, what are the DB design topics as per the interviews which are important, and after that, that's the bottom line. So basically, I was just trying to explore that how actually it works to extract the information from my PDF, which is quite big. So that is how you can see in a very good comprehensive way, I will be able to retrieve the information out of it. So definitely you can also go ahead and explore this specific page index chart and try to upload the PDF and try to see that maybe the bigger PDFs than this as well, and try to see that whether it will be able to extract very good insights or not. By the way, whatever topics this concepts with respect to interviews is mentioned over here, it is actually applicable for all the data ecosystem based interviews, whether you're talking about data analytics, data science, data engineering. And we already have a playlist on my channel with respect to the SQL from basics to advanced. So if anyone who wants to learn about this, they can definitely go and explore that specific playlist as well. With that, bye-bye everyone, and see ya.